Okay, now we're going to do division properties with exponents. So it's just the opposite of what we did yesterday. Instead of multiplying, we're going to divide. And if you'll remember, when I multiplied exponents that had the same base, I had to add the exponents. But since I'm going to divide, which is the opposite of multiplication, when I divide exponents with the same base, I'm going to keep the base, but I'm going to subtract the exponents. It's just the opposite of what we did yesterday. I'm going to show you with this first example why we have to move things that have negative exponents. This division example is going to make perfect sense. If I write this in expanded form, so x squared is x times x, and then on the bottom, x to the fifth, I have 5 of them. And if you'll go based on what you know about simplifying and reducing things, these x's will cancel each other, and these x's will cancel each other, leaving me with 3 x's in the bottom. But I don't have anything in top, except if you know that when these cancel each other, it's because they made a 1. So you have a 1 on top and 3 x's on the bottom, so it's x to the third. That's what this equals. But if you do this following the rule, and you subtract the exponents, you keep the base, which is x, and then you subtract 2 minus 5. Well, if you know your integer rules and you think about them, 2 minus 5 is a negative 3. Well, I can't leave it as negative 3 because I can't have a negative exponent, so I have to rewrite it as 1 over x to the third. This is the reason why negative exponents become written this way. Because when I write it all out in expanded form, everything cancels. I have nothing left on top, but I still have stuff remaining in the denominator. But this is the why. When I told you before, I was going to be able to tell you why in a couple days, there is the why, and hopefully it makes a little more sense now. But the first answer, the first one, is 1 over x to the third. You can write it in expanded form, or you can subtract exponents. So the next example, 3 to the 8th over 3 squared. My base is 3, so I'm going to keep my base, and I'm going to subtract my exponents. Well, 8 minus 2 is just 6. But if you want to really simplify this all the way down, you want to find out what 3 to the 6th power is. You take out your calculator, you type in 3 to the power 6, and you get that it equals 729. So I subtracted my exponents, then I went ahead and simplified down. Now the next problem has coefficients in front of the bases. So I have negative 3 and 15 are coefficients. So the first thing I'm going to do is take this negative 3 over 15 and reduce that, because it's a fraction I can simplify. I can divide them both by 3 and end up with negative 1 over 5. I don't know why I made my line so long. It was really unnecessary. There we go. Then my base is an x. And I can subtract my exponents just like I did with the other two examples, and 7 minus 3 is 4. So I reduced my coefficients down to a number, a simplified version, and then I subtracted exponents with my base. So I get negative 1/5 x to the 4th. If you want to write this in a simpler form, you could also put the x to the 4th up top. So you have negative 1 x to the 4th over 5. These are the same thing. If you want to leave it like this, it's totally okay with me. If you want to switch it to this, that's totally okay with me too. They mean the same thing. All right? So let's practice a little bit more. If you look at the next example, it's this one up here with the a's and the b's. I have a to the 5th, b to the 9th over ab all to the 4th. And so now we have to go back to what we did yesterday with the multiplication properties of exponents, and we have to simplify this. And so you should remember that I have to distribute this 4 to everything inside. So this really is a to the 5th, b to the 9th over a to the 4th, b to the 4th. Now you can subtract exponents with like bases. So I have my a's, and 5 minus 4 is 1, so it's just a to the 1st. And then on my b's, I have 9 minus 4, which is 5. Now, if you want to put the 1, you can. If you want to leave off the 1 and just write a, b to the 5th, they're the same thing. You won't see it with the 1 written on a test or in an example, but they do mean the same thing, and one is not more right than the other. Okay, I want to go to this next example down here at the bottom, the long one down here. It's very similar to the one that we did a few minutes ago. I've got coefficients, and then I have all these bases. Don't worry about moving negative exponents until after you have done the division part. Save the moving of negatives until the very last step at the very end of your simplification. So we're going to divide coefficients first. 15 divided by 5 is 3. Then I have to do my a's. I have a to the fourth, and this is a to the first, even though you don't see it. So I'm going to subtract 4 minus 1 is to the third. And then my b's, I have b to the first over 4. Now think about this for just a minute, because I'm going to subtract exponents. So I'm going to have to do 1 minus negative 4. And if you'll remember integer rules, this really means 1 plus 4. And the same thing is going to happen with my c. I'll simplify this down in just a second, because I have negative 3 and positive 3. Well, y'all should be able to tell me that negative 3 minus 3, it's not going to be 0, so don't jump to that conclusion. Here's what you end up with. So we're going to go ahead and simplify from here. I already had my a to the third because that was easy, but this 1 minus negative 4 really became 1 plus 4, so I have b to the fifth power. So you got to still watch your integers just like before. And then my c, negative 3 minus 3, is really a negative 6. It is not 0. It's only going to be 0 if I'm adding those together, but when I subtract it, I get negative 6. Now I can take care of the negative exponent. This c to the negative 6 has to go to the denominator. So 3, a to the third, b to the fifth stays in the numerator. The c to the sixth drops down here to the denominator. There's my simplified version of that expression. So let's practice dividing some more and simplify some expressions. Now this is going to put everything we have done all together, all in one big problem. So this first one, I have all of this taken to the power of 3, which means I got to distribute this 3 to everything in here, the whole numerator, the whole denominator. So I end up with 2 to the third power, because the 3 has to go with the 2. And then I multiply these exponents, so I get x to the ninth. And then in the denominator, the 3 also has to get distributed to those, so I get y to the third, z to the third. Well, 2 to the third you should know is 8. So you have 8x to the ninth over y to the third, z to the third. And since I now don't have any like bases, I'm done. There was no division that had to be done in this problem at all. I was just basically simplifying using what I have already learned, as I don't have any like bases. The next problem is very much the same. You have all of this taken to the fifth power, so I got to distribute my little 5 all the way through. So this becomes a to the fifth. And then my b becomes to the 20th, because I have to multiply. 4 times 5 is 20. And then same down here, I end up with c to the 10th, because I have to multiply 2 times 5, and d to the 15th, because I have to do 3 times 5. Again, I don't have any like bases going on. I can't simplify any further. I'm done with that problem. Now the next problem, this one, this 2/5 to the negative 3, I like this problem a lot, because it looks really complicated. It's not very complicated, but you will overthink it. The first thing I want you to do is distribute this negative 3 exponent to everything you see. So this really becomes 2 to the negative 3 over 5 to the negative 3. And you know from talking about negative exponents that they're not okay, so I've got to move. I've got to do a little switcheroo here. The 2 has to come down here to the denominator, but the 5 has to come up to the numerator. So I'm really just going to flip this over like I'm going to do a reciprocal, and my exponents are going to become positive. So I end up with 5 to the third over 2 to the third. Then I'm going to actually do the math and get 125 over 8. I like that one because it's just a little switcheroo kind of an issue, so that you don't have any negative exponents left over. So let's do 2 more. This one's very similar to the one we just did, only a little, it's just got a little more to it, but everything is taken to the negative 2 power. So I end up with 3 to the negative 2, x to the negative 2, over y to the negative 6, because I have to do 3 times negative 2. Now I got all these negatives. It's just like this one up here that we just did. I'm going to have to just flip-flop everything. All of this will have to go down here, and this will have to go up here. So I end up with y to the 6th over 3 squared x squared. Well, 3 squared is 9, so you have y to the 6th over 9x squared.